Hello, hi guys, good morning. Welcome back to the new video. And for sure, I'll say if you want to get the intuition, please skip the next 20 seconds. But if for the people who are actually watching this video and want to see, okay, you know why the binary search is working, but the logic that if it is possible that you want to get to know, just watch this video. For sure. Cool. Let's start the problem statement itself. It's very straightforward. Not that straightforward, but yeah. Maximum running time of n computers. It just says that you have n computers and you are also having an integer n. Just saying, okay, you have n computers, and also the indexed zero index integer array batteries, where I the battery can run a computer for the battery I minutes. So that battery, if that battery has a value 4, so it can run a computer for 4 minutes. And I'm interested to run all the computers simultaneously. That's a big word. Simultaneously is a big word, that all the computers should be running. If I say that I can run the computers for 5 minutes, I am saying that I'm able to run the computers 5 minutes simultaneously. Every computer is on simultaneously. Cool. Using the given batteries, and now I can initially put, and for sure I can always put at most one battery in each computer, which means every computer has just one compartment of one battery, which means one battery will only go in one computer. After that, at any integer moment, I can remove a battery and I can from another computer and insert into another battery into any number of times. So basically, I can also at any moment, okay, a computer having a battery, I can remove this battery and place another battery right at any time. And that switching of battery, it takes no time. It is just like instant. Cool. The inserted battery can be totally new, and the inserted battery which I insert, it can be new or it can be from other computer as well. Maybe I remove from other computer, I place another battery in computer. Let's say I have computer 1 and 2. I place battery 1 in computer 1. Let's say I remove the battery 1 from computer 1, place a battery 2 in computer 1, place this battery 1 in computer 2. So that is also possible, that okay, I am placing a battery, used battery in another computer. Cool. Now I can, and for sure, if I am placing a battery, it should have some battery left. As the computer keeps on running, the battery is being consumed. Please remember that part. You assume that the removing and inserting the battery takes no time. That I showed you before also. No, the battery cannot be charged. Battery, if it is being used, it is being consumed. Please make sure. Within the maximum number of minutes, you can run all computers simultaneously. So my task is maximum number of minutes I can run all computers simultaneously. So for sure, the first thing comes in my mind is, okay, I want to run my computers maximum number of minutes. So I just simply I'll simply ask myself, can I run my computer for 1 minute, for 2 minutes, for 3 minutes, for 4 minutes, for 5 minutes, for 6 minutes? I just simply ask me, because I just want, okay, I want to run for maximum number of minutes. So I simply ask myself, can I run for 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, 6 minutes? If I'm able to run for 5 minutes, okay, cool. If I'm able to run for I am not able to run for 6 minutes. So the maximum of minutes I am able to run is 5 minutes. That's it. Now, how long it can go? It can go up to 1e14 minutes. How 1e14 minutes? What if I had just one computer and let's say 1e5 batteries, with every battery having the minutes as 1e9? So in total, I will have, the battery power I will have is 1e14 minutes. So I can run my one computer for 1e14 minutes. So that's the maximum time it's possible. So for sure, I can't go linearly in 1e14 minutes. So for sure, the first thing comes in my mind is just let's apply binary search. So I can simply say, okay, how we apply a binary search? A simple stuff. We'll just simply go in the mid and ask him if it is possible to actually make all the computers, let's say I have n computers I can make parallelly, and simultaneously I can just run them for 6 minutes. Okay, if it is possible, then I'll try for the higher minutes. Okay, I'll try for higher minutes than 6. But if it is not possible, then I will try for the lower minutes. And that is how, because for sure, if I'm not able to run for 6 minutes, I will never be able to run for more than 6 minutes, which means more than 8, 7, 6. I cannot be able to run it, right? So if I am able to run it, I will just simply go on to the higher range. If I am not able to run it, then I will simply go for the lower range and I will discard the higher range. And that's a simple binary search. But now you got to know, okay, you can simply apply binary search on the number of minutes which you have. And for sure, you want to maximize the number of minutes. So you will just simply apply binary search on that. And that's a great part. But the tricky part comes in picture is, now how will you verify that your all computers, which means n computers, can run simultaneously for these x minutes? Let's say the mid is at 6 minutes, but it can be later at 8 minutes, it can be at any minutes, right? So how will you verify that you can simultaneously operate all the computers for X minutes. That is the prime problem of this particular. Binary search thinking is not at all the big problem. Thinking of, okay, how will you actually see the if possible condition? Okay, is it possible to actually operate my all computers for X minutes, for XYZ any minutes? Because this XYZ minutes is just a mid. Every time the mid will change, this mid will actually be your X minutes. But yeah, is it possible? That's the prime condition. Now, for that, we'll take simple example, very simple. If we have batteries, see, these are the batteries and the number inside the battery shows the time for which I can actually operate these batteries. It's 2, 4, 4, 5 and 7. Now I have these 4 computers with me for sure. Now let's say I am choosing, can I operate these all 4 computers simultaneously for 5 minutes, which means every instant it should have a battery consuming power. So for sure, I should have, at any moment of time, I should have 4 batteries plugged in, and for sure it should be giving power straight for 5 minutes, right? I can also switch, but I will not consider that switch time because it's actually negligible. Cool. Now I have these 5 batteries with me, 1, 2, 3, 4, 5. Now for sure, if I have a battery with a power as a 7, it can operate straight for 5 minutes. So I'll simply go and plug this in one computer because I know it can just straight off work for 5 minutes and I don't have to remove it. For sure, I don't have to remove it. Please make sure every word from here is actually very important. I'll straight off plug this battery in my one computer and I will never remove it. Why? Because I know he can give 5 minutes and he should be there in this computer for 5 minutes straight, because for sure it has a power to give for 5 minutes, so it should be there for 5 minutes straight. And after completing 5 minutes, it's of no requirement for me and also for others. Why? Because after 5 minutes is complete, which means I am starting with the 6th minute or the 7th minute, but I'm only concerned about 5 minutes. I'm only concerned if I can run all these 4 computers for 5 minutes. Have we understood that or not? I'm only concerned, are we able to run all the computers for 5 minutes? I'm not concerned about the 6th minute or the 7th minute. So for 5 minutes straight, it will be inside the computer 1, and that will give the computer, this battery will give the computer 1 the power. Now coming to the battery 2, straight also, it can also run straight for 5 minutes and it can just give the power to the next computer, which is the computer 2. Now comes the other 3 batteries. None of the batteries can straightly give power to any 2 computers. For sure, all of them are less than 5. So no one can give the straight power to any of the computers. So is it possible? So can I say, okay, it is actually 4, 4 and so it won't work? No, I will not say that. Why? Maybe I can just put in one battery, another battery, and then maybe I can remove one battery, use one battery. Maybe I can just do any combination that I can actually make them run for 5 minutes. What if it is possible? So I will just say that, can all these 3 batteries in together can run for 10 minutes? Oh, which means all these 3 batteries in average for these 2 computers, can it run for 5 minutes? Which means if all these batteries in total, it can run for 10 minutes and I want it for remaining 2 computers. So for sure, it can give me 5 minutes for both the computers. But Aryan, it is just numerical. How is it always possible? I'll show it is. See, I just know one thing. All these batteries are less than 5 minutes, which means none of the battery will actually stay in forever in one computer. It needs to come out and another battery needs to come in to actually make up that 5 minute mark which we wanted. So I can just say one thing. Okay, I have a battery 2, 4, 4, right? I'll just plug the first battery in the first computer for just 1 minute. The next battery in the next computer for just 1 minute. So it is being consumed for just 1 minute. Okay, 1 power is gone, remaining power is 1. 1 power is gone, remaining power is 2. Now the computer was on for 1 minute exactly, right? Now I just use this 1 battery extra because right now you saw I have 3 batteries, right? So I just use this 1 battery of the remaining power 1 in computer 2 and the 1 battery with the power 4 in computer 1 for again 1 minute. Okay, 1 minute gone, 1 minute gone. Here from it became 0, it became a 3. Now again I have just left 3 power in both the batteries. Now I can just simply plug in 3 power and I can just simply get it for 5 minutes. Here you saw it was again a 1 minute added, again a 3 minutes added, which is 5 minutes. So by using this extra battery and shuffling it in at just 1 minute time, which means I was able to utilize its 2 minute and was able to add these 2 minutes in these 4. That is the concept. Okay, I am taking the average of the remaining batteries, which is, it is giving me 10 minutes, because I know at every 1 minute time I will be able to add these up in my other batteries or indirectly in my other computers. So I will be, and by shuffling itself, I will be able to do it. And you will ask, Aryan, then why not you took the average for this particular number 7? It will also be able to add. No, it will not be able to add. Why? Because it will be straight in this computer forever for 5 minutes straight. At 6th minute, I can be able to bring it out. But I want for 5 minutes everything should run simultaneously. All these are running simultaneously, so I cannot touch it. But all these are not running. When, as you saw, when these two are being used, again, when it is being used, it is free. So battery should be free to actually go to other computer. So 1 minute I ran it for the computer 1, then it was free, I used it. See, when it was free, I used this battery to actually plug it into the computer 1, and again this battery to computer number 2, so that I can actually use. So basically, when I have okay, the battery power is less, but I have more batteries, so I can basically shuffle the batteries in to actually get all the power I wanted. Because for sure, if the battery power is less, which means it is less than 5, I will have more batteries to plug it in. So if I have more batteries to plug in, which means I can do the shuffling part, which means I can do the average part. So for sure, the average, which means the sum of the battery power remaining, please make sure it is the remaining one, not the ones which are actually gone into computers. It is the remaining one, and for sure it is for the remaining computers as well. So for the remaining battery power, I have the battery power as 10, and the remaining computers are also actually 2. So for sure, the average it gives me is 5, which means for sure average 5 minutes I can actually operate my computers. Aryan, what if the battery power would have been 3 here? So for sure, the sum would have been a 9 upon 2, which will give me something 4.5, which is less than 5, which means it just says I can operate all these 2 computers simultaneously for at max 4 minutes, not more than 4 minutes, which means I won't be able to operate for 5 minutes. So please, you cannot be able to operate for 5 minutes. Just try for a smaller range to search, and that's how I can actually get to know, okay, is it possible to actually operate these any computers simultaneously for these X minutes, because I'm binary searching on these minutes part. And that was the main crux. See, it was the most important thing. Thinking of binary search was not important at all. Thinking of, okay, how you actually find out what is the X minutes, how it is even possible to operate these simultaneously was possible because of these conditions. Cool. Now you can just know, okay, you have the extra. Please mark for sure. You had the extra battery. That is where you were able to actually replace the batteries. That is the reason I was not able to choose the number 7, because it was not the extra battery. It was already inside one computer and it cannot be used. While in this case, you know, we have 3 batteries and 2 computers, which means I have extra battery to actually plug it in. And when I say extra, for sure, these have the powers for sure less than what we wanted, which means 5. Cool. And that's how you can simply say that, okay, I'll just simply grab the total time upon the number of computers it wanted. If it is actually more than equal to the X time I wanted, for sure I can operate for these X time, for these 5 minutes I can operate, if the average is more. And if it is possible, then I will simply try for the bigger range, which means bigger minutes. Now to actually make it, because see, for sure, if you will be writing it down, then what you will be able to do it. Now you understood the logic. Now what you will do is you will write down, and what you will do in your code itself, you will just find, if let's say for 5 minutes, then you will just simply go and grab the higher value, which means you just ignore these numbers which are more than 5, and then for these computers as well, you will just ignore, and then you will only count for this particular number which are less than this 5, and to the average and stuff, but to actually make your so that you will not ignore, like you have to write bigger code, just ignoring the numbers which are more than 5, then counting the computers, then finding the remaining computers, and then counting the average. It will be through a bigger code to actually make it smaller, although it is also correct. But to make it smaller, what we can do is, we know that all these numbers which we saw, battery numbers which are actually more than equal to 5, all these will not impact or should not impact my average. Ultimately, I am concerned about my average, which is the total time upon the computers. Here it was 2, right? Plus the 2 for the computers which are actually more, having the batteries more, the computers which I showed you above. So I just wanted, okay, it should not impact my average. So what I will do is, rather than placing a number 7 which is more than 5, I know it should not impact, which means the extra time it has, it should not impact my extra time. So I'll just reduce all these numbers to actually this number 5 which I wanted. So I'll just reduce them to 5. Why 5? Because it is a 5 I wanted, and if it is there 5, 5 and 2, it will not impact my average. That's the reason I just simply added it. Although if you don't want, or if it is a bit complex for you, just ignore the numbers which are having the higher value with time, and just get the numbers which are higher, like lesser than value than the time, and also the computers remaining, which means for the numbers higher value, all the computers were already been fully charged, will get charged. The remaining computers you will actually be concerned of. If you don't want to get into that condition, just simply bring all the numbers which are higher than 5, higher or equal than 5, to actually bring it to 5, and also with that the average will never get affected. And that's how you can simply get your total time upon the computers, which should be greater than equal to the time. And this is the time on which you will do a binary search. Let's quickly jump to the code. It's very simple. Firstly, I will have a simply low and a high. Low, you can simply say, okay, it says 0 simply, and high, to get the high, as I showed you, it will be nothing but the sum of batteries, right? So as the high we showed here, if we have n batteries, let's say we have 25 batteries, and every battery has the a minute of 1e9, so for sure I can just say 1e5 into 1e9 will be the total minutes, which we saw it is 114 minutes, right? So here also, if we just want, we can just go and find the sum of minutes of every battery to just get the high. Or if not, you can just simply place 114, and also it is the maximum which you can get. You can also place the 114 and it will also work. Now coming back to, either you can do this or you can do this to get the high, anything you want. It is a bit like the high will be a bit shorter and bit more precise. It's just a maximum which by the range you can actually see. Now coming on to actual binary search, while low is less than equal to high, I see whenever it is low less than equal to high, we know that, okay, we do a low mid plus 1 and high mid minus 1, and we also keep on taking the answer parallelly, because ultimately I'm returning the answer. Now if it is possible to actually get those mid number of minutes, right, the x minutes we saw, it is the mid number of minutes on which I'm doing a binary search. If it is possible, then I will try for the bigger range. If it is not possible, I will try for the lesser range. Now if it is possible, which means if it is possible, that is the main condition which we wanted. Simply going on to back, I'll just find that simple stuff, the total time upon the number of computers. Number of computers will remain for sure n, which we saw above, and it should be greater than equal to the time, which is the binary search ka time. It should be greater than equal to the binary search ka time. Now coming on to the sum, which is, because computers we know, this time we know, we want this total time. Simply as we saw above, that how we will find this total time, we'll find like this: anything which is less than this time, we will simply add it. Anything which is more than the time, we will simply add the time itself. It is the time, anything, and let it is the B time, which is the battery time. Anything, if the battery time it is less than this time, then simply add this battery time. If the battery time, if this B time, if it is actually more than this time, then simply add the time itself here, not the battery time. As simple as that, right? So I just simply do the same condition. If the battery time is less than the time, then simply add the battery time. If the battery time is more, then simply add the time itself. And by this you will get the total time, and you will just find, okay, if the total time upon this computers, if it is more than equal to this time. Simply going on and multiplying this computers on the right side, and simply getting the same condition, right? Same condition as here, so that you don't have to go into the division and stuff. Just simply do a cross multiplication to find, okay, the simple linear condition. And that's how you can simply go and find your answer. Cool. And the capacity is nothing but O of n into log m, n for batteries because you are going on to every battery at every if possible, and for log m, m is the sum of all the minutes, right? As we showed above, it will be roughly O of 1e5 into log of 1e14. Cool. The code is down below and it should be pretty easy, and specifically I try to focus primarily on if possible part because it is the prime condition that no one has ever explained. I don't know why, but people just go on to binary search. Binary search is very easy intuition for this problem. It's just that how you find is possible is the main part. Cool. See you in another video again. Bye bye.